Hello, today I'm going to show you how to find the general solution to this differential equation. So we're going to use separation of variables, so what we need to do is bring all of our y's to the left hand side and everything else to the right hand side. So we'll start off by factorising and we'll bring all the y's out that we can. So we'll have dy dx, and now the 2xy and the y both contain a y, so we're going to have y lots of 2x minus 1, and then what's left over is another 2x and a minus 1. And what we can see now, if we put brackets around this bit, we can factor out a 2x minus 1. And we'll see the other bracket then is going to have y and a plus 1, where the plus 1 forms this second one over here. So our next step then, we want to bring all the y's to the left and leave all the x's on the right hand side. So what we're going to have is 1 over y plus 1, still multiplied by dy dx. Well, for now it's just going to be dy. And on the right hand side, we'll have dx minus 1, and we'll put the dx over there. We've treated this like a fraction, the dy dx, like we've multiplied the dx to this right hand side. We can't always do that, but it works for separation of variables, so we kind of allow it, as long as we integrate immediately. So the left hand side, we're going to get the natural log of y plus 1, and on the right hand side then, we're going to get x squared minus x, and then also plus our constant of integration. Now then, we'll take exponentials of both sides. So left hand side is y plus 1, and the right hand side is e, the x squared minus x plus c, which we can use power laws to be like, well, this is e to the c, and then put all the x's in another exponential. The reason we do that is then this thing we can think of as like an a, and have that as our constant, not constant of integration, but the scale factor we can use later on. So like if we wanted to find the particular solution, we're just finding the value of a instead of the value of e to the c. So what we have now then is y is equal to that e to the c, which I'll write as a actually instead, keeping with what we've said. So a e to the x squared minus x, and then our plus 1 from before becomes a minus 1. So this plus 1 is now a minus 1. And this thing then is the general solution to this differential equation. Beautiful.